Crewton Ramone's House of Math. Start this lesson at last. I hate to erase it because this was actually a bit of work, but oh well.
I sent you a screenshot.
You got the screenshots, exactly, it's fine.
Yeah, you got it.
Okay, and I took a shot of it also. Okay, I just gotta catch my breath. Alright, 5 basic concepts, right?
Right.
And last week we played and did, we did all kind of fun stuff. We did problem solving. We were factoring polynomials. Let's start with factoring polynomials because it's fun. And we just need to get bigger. Okay, so you got your blocks handy?
Yep.
Alright, so you need 2x squareds this time.
Okay.
Alright, you can't see what I'm writing down here, can you? See, because here's what I'm doing. Nope, you... Oh, yes, you can.
Yeah.
Oh, boo. Alright, so see? I gotta...
Oh, you don't want me to see
I don't want you to see that. Let's go up a little bit. There you go. Okay, yeah, alright. You can't see down here and you can't see... Okay, so because I'm going to draw... Because what am I doing? I'm just drawing pictures. Alright? And then translating them as pictures into symbols. And then you got to figure out how to turn it into a rectangle.
Right.
See how it works? So, let's see here. We'll start with an easy one. I got a lot of these memorized. I've done so many of them. Let's just start off with 2x squared, 5x, and 3. Set it equal to 0, so you got to give me the zeros, right? There's 2 answers. It's all positive. It's easy, right? Like we're just getting warmed up. What are you doing anything for President's Day? Me either. I'm serious. I have students that are just like, it's a holiday. We can't come to class. All right, whatever. Math.
Yeah, no.
Math doesn't really care what day it is, but all right.
I've never taken a day off for President's Day.
I can't think of a time either. Well, except for when I was like in, many moons ago when I was in public school.
When I was in kindergarten, that was probably the one.
Yeah, there you go. When I was in kindergarten, President's Day was George Washington's birthday. And then they just turned it into to all the presidents, not just George Washington.
Yeah.
That's how old I am. Yeah, because there'd be like Lincoln's birthday, Washington's birthday, and then they just made it all, just call it President's Day.
Yeah.
Because otherwise we'd have like 45 holidays.
Exactly. 45 school days off.
You can't have that. Alright, so. Got your red.
Yep.
I'm going to use interesting colors.
Laying it all out now.
Yes. I'm going to use pink and blue and orange just to be weird. So let's see here. 2x squareds. Now see, we like 2 because there's only 2 ways to build 2. That and that, right? We also like 3 and 5. But 4, when we get to 4x squared, sometimes it could be like this. Maybe it's like that instead. Right? And the same thing, 6 and 8, the other ones that are factored. But we're not going to get too high over here. But we just got to get used to the fact that you can factor any of these. And then recognize, the patterns and how it works. Which ones are factorable and which ones aren't.
Yeah. I'm having the same problem that I had the other day.
Are you having a problem factoring this?
I think I got it.
Alright, let's see it.
Yeah, I got it. It's definitely a second, but I just had to rearrange. There we go.
Yes, you got it.
Yeah.
Alright.
So we've got x squared.
Wait a minute, we're just reading across, so this would be 2x.
Right.
This is 2x by x.
Yeah. 2x.
Plus how many?
Plus 3x.
2x plus 3.
2x plus 3.
There you go.
My bad.
Is that way.
And then
well, then the other guy's gotta fit like that, right?
Then you got times.
How's that for
2x.
For colorful.
For x.
It's Dadaism. No, anyway, it's. Why would I use red, blue, and green when I could use pink, turquoise, and orange?
Quirky.
Quirky, yeah, there you go. Alright, so you got it. Now you just got to solve for x. So yes, the factors are 2x plus 3. Right, because we're just counting the distance. I want to cross an x, I want to cross another x, and then I want to cross 3. Right, I'm not counting the whole thing. I'm not counting the area as I go across. I'm just counting the distance from here to here is 2x plus 3. Right?
Right, it's width by height.
Right, exactly. So that's the across. And then up, it's just x plus 1. Super easy, you can see that. Anywhere along here, it's x plus 1. So from here to there, that, and I should write it sideways, x plus, oops, 1. You can almost see that. That's supposed to be an x. Right?
Right.
Okay.
Okay.
So solve for 0. One of them's obviously, I'll give you the easy one. I'll do the easy one. The easy one is -1. What's the other one?
-1 and
Negative.
So that's the second group. Right?
That's this one. All right, fine. I'll do it that way. So
This other one.
fine.
Right.
Do like that. All right. Brah. 2x plus 3 equals 0. I'm gonna show you a shortcut in just a second.
3. Oh, negative. Yeah, negative. I'm thinking. Hang on.
0, 0. No fun. Go back to 1.
It's a 2. Oh, right. I can get rid of. I forgot. I can get rid of it.
Yeah. See. See. We're doing all of it at once. We're doing our problem solving. We're doing our algebra. We're doing everything at once. 0, 0. No fun. Go back to 1. Help! Help!
Isn't that 0 over 2 then? If you're getting rid of 0? I mean, oh.
Is this not 0 over here? Is this not just 3 minus 3?
Right.
Well, then I take away the stuff that's same.
Same.
I'm using symbols. I should be using blocks.
2x equals negative. Oh. You see, I didn't think of it like that.
There you go. Well, start thinking of it like that.
Okay.
And then what? Do I want to know about 2x?
No.
I do not want to know about 2x. What do I need to do?
Divided by 2.
Divide by 2. That's the no fun, get back to 1 part. Oops. And then you write the 3.
Negative 3 over 2.
That's it. And can you see what you're going to do?
Yeah.
It's just going to be negative 3 over 2. Right?
Right.
So now, okay, so negative 3 over 2. Or I could say 1.5, but let's just leave it as a nice fraction like that. Improper.
Right.
Okay, now, just for fun, okay, and that's it. And if you put them in, let's put them in just for giggles, right? And it was great. I had this little girl last week where she's doing awesome, or wait, not awesome, she's doing amazing, she said, in fractions at school.
Mm-hmm.
And this was a girl that they'd put all kind of stupid labels on that were stupid. And I showed her that, yeah, you can do this stuff. Then all that, those labels just, all it means is that your teachers didn't know how to teach you. Anyway, but the idea is that she's now doing amazing in fractions, and so we made some problems like this that had fractions in them so that she could practice her fractions. Because now, look, what do I have to do? Well, now I have to say that this is 2 times -1 squared plus 5 times -1 plus 3. That should be the same thing as 0. Well, let's see here. What's 2 times, what's negative, right? PEMDAS, please. Elvis must dance and sing, right? Or please, excuse my dear Aunt Sally, or I've heard a lot of them, but anyway, whatever it is, right? So first we do this, right? And technically it's this, when you get right down to it. Inside the parenthesis. So that's just 2 times 1 is 2, plus -5, because 5, right? And there's plus 3, and, right? There it is, 0. All right, I did the easy one again. Now you get to do the one that has a fraction in it.
The fraction. Okay, so you have 2.
So I got to, here's to do it. We just put in here, we'll put x.
Right.
All right, so that we don't have x anymore, we don't have x squared anymore, we have negative 3 over 2 squared, 2 times, plus 5 negative 3 over 2's, plus a 3. All right, so this is going to be the first one. What's this one?
negative 3 over 2 squared, so that's just... So don't you just square both?
There you go. That's see, and that's why. See, you gotta do it. Because what does that say? That says negative 3 over 2 times negative 3 over 2. And this is where you got confused last time, is because you can't just you can multiply like that, but you can't add like that.
Right.
So they don't have to be the same when I multiply, because I'm taking a number of times, right?
Yeah.
But they do have to be the same when you add them or subtract them, or technically when you divide them. But we have a shortcut when we do division, where it talks about,
you're doing the quotient.
right, where we just do invert and multiply.
Yeah.
Do the old flipperoo, right?
Yeah.
As you said, I like it.
Yeah.
Okay, but here we just go straight across. What do I get?
Right. So you get.
And a negative times a negative is
9.
Yes.
9 is a positive.
Yes. So 9 over
9 over 4.
9 over 4. Done. What's 2 times 9 over 4? Well, 18 over 4, isn't it? Because this is 2 over 1. This is the one thing that the little girl was having difficulty with. She thought it was 2 over 2. I'm like, 2 over 2 is 1! So you have to multiply, right? Actually, it was 4 that she was doing. She was doing 4 over 4. But 4 over 4 is 1. So it's got to be 2 over 1. So we just multiply it out. I just made this fraction twice as big. Right? Because I just made the numerous, I made it the numerator twice as many. But the denominator, the kind, stayed the same.
Stays the same.
Right. All right, so now over here, what have I got? Well, now I got to multiply 5 over 1.
Right. So then you have 15 over 2.
Negative 15 over 2.
Negative 15 over 2. Yeah.
Okay, plus the 3. Gee, does that equal 0? You got some math to do, Holmes.
Well, it's not the same. It's not the same right now.
It's not the same right now. We got to do what?
We have to multiply it by 2.
Okay, we're gonna do everybody. We're gonna actually we're gonna multiply by 1.
By 1.
2 over 2, right?
Right.
So this makes this 30 over 4.
30
over 4, right?
4. Right. Wait. How did that happen?
How did that happen? I love it. I multiplied. That is an excellent question. What just happened? No, that's good. See, and that's why. Look, we started off with this one problem. Look at all the math we're doing. See, because what they do, you know what they do in regular school, quote unquote regular school, or I don't know, you call it public school, or I don't care. Some Montessori classrooms, I've been appalled. I've been in a lot of different places where they have these tremendous tools and they don't understand the technique. But the idea is, from just this one problem, we are learning problem solving. We are learning distribution. We are learning about negative numbers. We are learning about fractions from just this one problem. Right? You got to do it all at once. All right, and then see, because a lot of times they do is they just factor it, and then they never go back and evaluate. Right? Because that's what we're doing. We evaluated. First I evaluated for -1. That was super easy. Now I'm evaluating for this fraction, which is not so super easy, because we got to do some little bit of work. But all right, so what I had over here was I had 15 over 2. And what I did was I said, well, I can't add these because they're not same.
Right.
So what I need to do is I multiply by 1, because when I multiply by 1, I don't really change it, do I? I do 2 over 2. That's a 1.
Yeah.
Isn't 2 over 2 1?
Yeah, it is.
Now, when 2 times 2, I get my common denominator, which is what I want. And over here, I have 30. That's what just happened. And it's negative, by the way, because that was a negative 15 over 4.
Oh, okay, so it is the same thing as multiplying it by 2 on both sides. Just thinking of it as a 1.
Put it in your own language, exactly. It is a 1, and it's 2 over 2. Yes, exactly. Right? Because what we're trying to do, we're trying to make a common, right? Okay, well now I have a problem, because now I have over here, I have a 3.
3 over 1.
Well, how many 4's kind is that? Well, if I do 3 over 1 and I multiply 4 over 4, why am I doing 4 over 4? Because I want a common denominator.
Right.
So I'm going to have 12 over 4.
12 over 4, right. And then it's also...
And positive, yep. And now 18 plus 12 is 30. And I have negative 30 over 4, right? So I have positive 30 over 4 and negative 30 over 4. And that's a big fat 0. All that work to get nothing.
Right.
Right?
Yeah.
All right. See it?
Yeah.
Because this isn't just 12 divided by 4, 3.
Yeah.
But see, before I can count, concept number 2, hugely important concept. They must be same before I can count.
Same.
Right? So now they're all same. I got 18 of the fourth kind, negative 30 of the fourth kind, and 12 of the fourth kind. Right?
Right.
And before I had all these other crazy different things, right? But now I made them all same. Because I had some of this kind of number, I had some of this kind of number, and I had some of that kind of number. So I need to make them all the same kind of number so that I could add them.
Right.
And figure out if it was actually 0 or not. Alright. Put your pencil on paper and take some notes. And put some English in your notes just like you did. Right? Translate this and make sense. And you should sit in on this lesson.
Okay.
My errant son has returned from traveling.
I am going to take a minute to write all
Yes,
that.
absolutely.
Okay.
That way when you look back at your notes, and I have another young lady, she writes excellent notes, she really does. She's not coming today because it's President's Day. Actually, there's a whole lot going on in her house, so she totally got a break. She secretly told me that she would rather be doing math, but she doesn't have an option, so. And that cracks me up, because if you met this girl, there was a time in her life when she would rather do anything but math. Right? Including going to the dentist. I mean, anything but math. Now, she actually likes math enough that she actually has a fairly, well, to me it seems like a fairly fun day, but she doesn't, she's a teenager and so on.
Right.
I'm like, go be with your family. Everybody's got a day off. Just go get together and do stuff. I don't know what they're going to do, but anyway.
Okay.
Okay, got it?
It was, one second, let me just write down the negative 15, because that's...
Yeah, this part, right? So like I said, up here we're just fooling around with distribution and making rectangles. Down here we're fooling around with solving for, right, problem solving. Down here we're fooling around with fractions. But did we do anything other than the 5 basic concepts?
No.
Nope, because we can't, because there's only 5 basic concepts.
Right. 2 over 2 is minus 1. Okay, there we go.
Got it?
Yep.
Let's see your notes. Just hold them up to the camera.
Look a little...
It's fine if you get, as long as you can read them.
Yeah.
All right, hold it closer.
Yeah.
Yeah, there you go.
Yeah.
All right, and like I said, okay, so wait. Put some English in your notes.
Yeah, there is a...
Oh, put it closer to the camera. All I can see is math symbols. Oh, more English than that, like complete sentences. I'm same. That doesn't count it. You can't. This isn't enough. You can't just put same. Over here, you need to. What did you do to make them same? Just like you said. What just happened?
Right.
Okay, so put some English in there so that you know. Yes, they got to be same, but the way you made it same was by multiplying by 1.
Right.
I like it. That's good, but that's a little too shorthanded.
Right. 15 over 2. 5. 1.
And then she sent me her notes, and I'll show you some notes. This person takes really good notes. She does. I mean, they're beautiful. And she does it on, on graph paper. And her writing's all girly neat and stuff.
Yeah.
Yeah, so it's easy to read. All right.
Okay, same. Right, and then you have...
And then you gotta, right, so everybody's gotta, right, so what do we do over here? Over here, we were doing hero 0. No fungi back to 1 is all we're doing every time. But over here, we did no fungi back to 1. We had to have different things to make them same. 2 over 2, 4 over 4, etc. Because the denominator, we gotta make same kind.
Right.
All right. Look, we've only managed to get one problem done. And we've been going for 20 minutes. But see, that's the thing. There's a lot in this one problem. And then, see, the first ones take a long time, and then after that it gets faster and faster.
Right. Okay. I'm almost done.
Yep, no, bro, we're in no rush.
4 plus.
And see, the next time your mom pays for tutoring, you get all my passwords. And then you can go to my website and think around all you want. I did some math, and I was doing math completely wrong because I was being a bone. But I have now, where am I at? I'm going to write over here, and I'm going to write over here. I have 960 videos on YouTube. I will have, and see, after today, and I would have had more. I had such a cute video this morning that I missed because I forgot to bring my camera. With this little 5-year-old girl, we're just introducing her into fractions, and she was hilarious. She's funny. Anyway, because, you know, fractions don't work quite the same as regular numbers, right? And then we're doing all this other stuff, like she's factoring polynomials, and she's doing problem solving. She doesn't even know the names of all the numbers yet. I asked her which one was 11, she pointed to the 100. You know what I mean? Like, she's 5. And, like, the whole concept that this is 100, 110, and 1, right? And we got into a brief argument over, that's 3. It's not 3. That's 111. It's 3 when you're a little girl, and if you're Roman, but if you're doing base 10 mathematics with Crewton Ramone, that's 100, 110, and 1.
100.
Right? Anyway,
Right.
It was a great video, and I didn't get any of it because I didn't bring my camera. But that was the best, because we had a discussion about it. She's 5, and she was using her logic and reasoning skills, and I told her to never trust a teacher. Right? So she questions me occasionally, and she's 5. It's awesome. Anyway, but I mean, think about it. 960 videos, and some of those videos are an hour. Some of those videos are 4 hours long, right? Because I have trainings and so forth. If you did go to the Module 2 part, you don't need to do the training quite yet. You probably need Module 3 and Module 1 is the ones that are going to be most interesting to you. But the idea is that with 960 videos, most of them are more than half an hour long. Some of them are short. Right? But back in the day when I first started YouTube, you could only make the 10-minute video. And then they moved to 15, and then finally they went to unlimited with kind. So anyway, there's a lot of short videos too. But even if you watch 6 videos a day, how long does it take you to get through my website? Well, the answer is years.
6 videos a day?
Yeah. Or not 6 videos a day, 6 videos a week. God, if you watch 6 videos a day, I mean, oh my God, that's like that's watching my channel 24/7. You don't want to do that. You want to do like one video every once in a while and go through them, right? Or you get on a topic that you like and you watch maybe 3, 4, 5 videos, right? Right. But the idea is that if you watch 6 videos a week, right? So let's say 2 videos for 3 days out of the week, right? And the other 4 you don't watch any. It's going to take you years to get through my website.
It's still going to take forever.
Yeah,
right.
that's what I mean. There's lots and lots of material there. Now, some of it you're not going to watch because you don't want to watch videos like place value videos and stuff like that, right? You got that pretty much wired. That's not a concept that you need help with. But maybe some of the fractions videos. Definitely some of the algebra videos. Definitely some of the problem solving videos. Right? All right. And then I got trig and I got Pythagorean theorem and you know, all kind of fun, quote unquote, higher mathematics where we get into quadratic equation. It's all there. Okay, now the idea is that we're doing tutoring, but you can supplement and be ahead of the game by spending some time fooling around on my website. Right? And like I said, for you it's a super bonus because in addition to the tutoring fees, you also get passwords. And those passwords are about to get knocked up to $9.97. So,
wow.
Yeah.
Yeah.
$250, but it'll be well, that's for a lifetime. If for $365, you can get a year of access, $1 a day,
right? And
you get all the videos. But like I said, in a year, you'll have a heck of a time getting through all my videos. Right? So I'm finally at the point where I can raise my price. I just have a couple little more things to do. All right. So you might want to play on the floor with some blocks. Seriously.
No,
not you, him, my son. Oh, come on and say hi. Put your face here. This is Will. Hello there.
Oh, hello. Hello.
He's in the background. Or you can just play, or you can just draw him. I don't care. You're pretty much at the point where you've been doing these. He's been doing this since he was literally 3. Right? Playing with blocks, sticking them together. I have video. I can prove it. Alright, so let's see here. How about 2x squared plus, we'll do the next one, 7x and 6. This should be a gimme. Gimme factors. 2x squared, 7x and 6. We need to start going through a few more of these at a little higher speed, so I'm not going to do the whole boat on this one. You're going to do some of that for quote unquote homework.
No. Right.
X. Stop.
Okay.
Write it down. Draw a picture. See, he's fooling around with blocks.
6.
6.
7x. 1, 2, 3.
7x and 6. And I'm going to tell you,
4, 5. Oh.
you try to use that kind of 6, you're going to have a bad day.
Yeah, no, I'm doing by 3.
Alright, there you go. So can you see that first factor is the same?
Yeah.
Alright.
I think I gotta see what it looks like.
Yeah. Get them all on top and then fit those guys in there. Yes, there you go.
There we go. There we go.
Yeah. Aha!
Yeah. Uh-huh.
And you got?
So, yeah, you got 2x plus 3.
2x plus 3 again, and x plus?
And x plus 2.
There you go, I just made it a little bigger. Right? I just added a row, basically. And wait, let's do my Art Deco thing over here. I didn't realize how important it was to use goofy colors when it comes. Boys, not so much. Girls, absolutely. Color is important to the female. They see more colors than we do. They're almost never colorblind. It's very rare for a woman to be colorblind. I mean, there are colorblind women, but it's pretty rare. Meantime, with men, motion. We need motion. Right? Our peripheral vision is better than theirs. And this is why men and women, we complement each other. One is not better than the other. They're complementary.
Right.
Getting you guys to fight with each other over gender is painful. Anyway, all right. So, obviously, what are my solutions for 0?
Okay, so you got, well, the easy one is -2.
The easy one is -2. We'll put that second. The other one is what? Again, it's the same.
It's the same thing. It's the -3/2.
There you go. Done. Oh, that's a quick lesson I was going to do. All right, so if it's 2x plus 3 is 0, then it's just x is 3/2 negative, right?
Right.
All right, what if I change this to negative? Then what? Now that just changed to positive, doesn't it?
Yeah.
What if I change this to 5? Then what?
Then it's not, it would be a -3/5, wouldn't it?
Well, it's still negative over here. So it'd just be 3/5.
Positive.
All right, fine, I'll do that then. And we'll make, and then you're, okay. Look at me working to make you right. Okay, so see it is?
Yeah.
Right, so you see, you can make up your own little rule there. I'm not telling you any rules, but I mean, do you have to do all the math and so forth, or can you just go straight to 3/5 negative?
Right, you can just go straight to it.
All right, what if I had 7 over here? Then what?
Then it would be -3/7.
Is this hard?
No.
Didn't think so. All right, what if I change this to I don't know, what if I change this to 5 over here? And I make it negative, then what?
Then you got +5/7.
There you go. You see? Do I have to make a rule for you? I'm not making any rule for you. You make up your own rule. But I mean, you see how easy that is to just, boom, done.
Yeah.
I don't have to do all the steps. I just come directly to here.
Right.
Okay. But see, now you know why. And if we play blocks, and we will play more blocks, you'll see what we did there. And your subconscious mind has no issue with it. Otherwise, it's just memorization and you forget.
Right.
All right. We're jamming. All right, so you're going to, at home, on your own time, you're going to evaluate for both of these numbers.
Okay.
Right, put the 2 in, put the -3 over 2 in, etc.
Okay, for this problem?
Yes, for all the problems henceforth.
Oh, okay.
Right, so this one, yeah, because like last time we did it all, right? But this time, you know what to do. Do it at home, see if you can.
Okay.
And if you can't, and it's not an issue, you come back and we'll talk about it. But I'm pretty confident you can.
Okay.
Right?
Yeah.
Because
No,
it's just the same thing.
Yeah.
Again, once you understand the concept, all I can do is change the numbers. Right? Because it's the same thing every time. We just change the numbers, just different numbers. Make sense?
Yeah.
All right. Well, let's get bigger. Did you get that? All right. Let's go with 2x squared. We're still just fooling around with 2x squareds instead of 1. 2x squareds. And we'll come back down to the quote-unquote easier ones in a minute here. And we're going to go with... Really? Can I do that? Yeah, let's do 2x squareds. Let's get bigger. 8x and 8.
Okay. So plus
Factors.
8.
Give me factors.
Plus 8.
Yes.
Okay. So we got boom. We got 7, so I'm gonna guess.
I'll give you another hint. If you try to use that one, you're going to have a bad time.
Yeah.
There you go. He shows me his 2 floors. Excellent.
So it's the same thing.
Alright, so what you can be doing in your spare time is evaluating the other one. Checking to make sure it equals 0.
Okay, so we got 2x plus 4.
Ooh! These kids, I don't think there's going to be, these children, excuse me, I don't think there's going to be any kind of issue. Anyway, but yeah, see, you should protest heavily when they don't match.
Okay.
Alright. Let's do another one. And like I said, you just sat there nodding like a dork. Took a while, but he figured it out. Anyway, I've done this to him many times, especially him and this other girl. I lead them down primrose paths, and they just la 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 la. And there's a dragon down there, but la 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 la.
Occasionally, we'll think you're leading us primrose down.
And see, and that's the other thing. Sometimes I do, and see that's my favorite is when they think I'm leading them down a primrose path, and actually I'm doing the math right. That's my favorite. And see, this is the thing. Dude, well, no, but this is the thing. With math, there's no argument. This is not opinion, right? That's 6.
Right.
But the only time that's 6 is if that's 1. Right? Because that could be 2. And you know when it's 2? If that's 3. Or excuse me, if that's 1. So if that's 1, this is a 2. You gotta know what your 1 is. But there's no argument. And I can change it. I can make that a 3. If that's 1.
Uh-huh.
Right?
Right.
Oh, I'm stressing your brain. I can tell. Wow. Okay.
No, it makes sense. It makes sense.
Yeah. No, but I can tell your subconscious mind is going, all right, slow down. All right, so let's go back to what we were doing and stuff you know. All right, so let's go with 3x squared. Oh, we got an extra x squared.
Whoa.
How about 3x squared? Oh, this is a good one. Let's go with 9x and 9. If you're a little kid, this is actually a problem about counting by 3s, but you're a big kid, so this is just a problem about how do we factor this. Because you can already count by 3s.
Yes.
Oh, I'm wrong. 12x.
12.
There you go.
Done.
What is it?
You've shown me this problem a few times.
Yeah, I know. All right, so forget it. But write it down and do the evaluation.
1, 2, 3, 1, 2, 3, 1, 2, 3. I have to put these over here. And there we go.
And see, it was what is this? This is our fourth. This is our 4th class, isn't it?
This is our 4th class.
Yeah. See, it's a 4th class before I start throwing curveballs at you. but you should still be able to bat. You should still be able to connect.
I'm able to fit 1, 2, 3, 4, 5, 6, 7. Oh no, because
There's only one way to build 9 with this. You do not have an option. You cannot. You certainly can't use a straight 9.
I forgot to add.
So the only other way to do it is a 9, like this. He said almost. Stuck. What? You know what's interesting? That was very, very interesting. Is that we had a hurricane come by here, and this is how I know that they're electromagnetic events, because we had a hurricane come by. It didn't hit us. It didn't hit us directly, but it was kind of spitty, strange weather, right? And my magnets wouldn't stick to the board. Like, you have to put them on very carefully. Like, right there, boom, I can put it on. But if I did it like that when the hurricane, it would just fall off. They're electromagnetic events. I don't understand it, and certainly I don't have, but I understand the concept that they're electromagnetic events. That a hurricane isn't just, some thing. Anyway, that's just plain old weather. There's more going on there. All right, I'm going to draw. Can I draw that? Let's get crazy. Do you see a red pen over there anywhere? All right, now let's go with the red. Those are my red squares. I've got 3 of them. Let's go with this kind of blue just for fun. All right, 1, 2, 3, 1, 2, 3. See, and I almost didn't count the other 3. Wish I had 9 there instead of, right?
Right.
Gotta count everybody.
1, 2, 3.
And so what are my factors?
So you got 3x plus x times x.
3x plus, well, what? 3x plus how many?
3x plus 3.
There you go. So my factors are 3x plus 3 and
3x plus 3 and then 3. No, sorry, x plus 3.
there you go. X plus 3. So one answer is -3, obviously, and the other answer is -1. See how fast I am? This is 3 over 3, right?
Plus 3.
And it's got to be negative.
Equals, right. -1, 3. Okay.
And what you're going to wind up is 12, right?
Mhm.
And -12. And the other one you're going to wind up with -36 and +36.
Yeah.
Got it?
Yeah, got it.
Because this is just going to be 27 plus 9 more.
Right.
Okay.
Yeah.
All right.
And you get 36.
Let's fool around. Let's fool around with some negatives. Time to introduce the negative concept to you. So, x squared. Got it. Alright, so now I am going to do x squared -1, and we got to figure out how to factor that. That's actually difference of 2 squares. So I'm going to start with that. Alright, so I'm just going to have... Go take some black seed oil. Sugar last night, I know it. So, x squared -1. We have to factor that. That's the difference of 2 squares.
Okay. So we have to get.
And go blow your nose, for God's sakes.
So then couldn't we like in theory just put it over?
Oh, that's getting good. Yeah. You're getting close.
Yeah.
Pretty good idea. In theory, I like it.
So then.
Think a minute. What can we do?
Oh, we have to do it with one of these little things.
Yeah, you need a 1 there. Now here's the thing.
And then put it.
That 1. Yeah, there you go. That 1. goes right here. It's minus, right? It's cut off. That's that x squared minus that 1. See it?
Yeah.
So put your little x squared on there. All right. Well, now if I look at it, I got this shape. I have this shape. With a little corner cut out. Well, that's not a square anymore. And factory means form a rectangle, count the sides, right? I should make that bigger so it shows up on the camera. What I have is this shape. There you go. Basically.
Right.
All right, so here's what I'm going to do. Things suddenly got negative. What happens when things get negative?
Well, then wouldn't it be, instead of adding, you'd be subtracting?
Okay, but what do you need when things get negative?
Oh no.
Well,
You need a hero! You need a hero! Help! It's got negative! Help! We got negative! You need a 0! Help! Hero 0! Hero 0! Watch.
yeah.
I added 1. But I can't just add 1, that changes their thing, right? Especially if I
Right.
have it set equal to 0. And that should be painfully obvious what the answer is on that one, right? But look, I just added 1. Well, can I just add 1? Well, the answer is no, I can't just add 1. So if I add 1, I have to take away 1. And if I take away 1, if I add x and I take away x, what did I add?
If you add x and take away x, well then you
Added 0.
1.
I just added 0.
Added 0.
See, normally, if you were here, I'd make you hold your hand out and I'd have an x. I'd give you an x and I'd take it away again. What's in your hand?
Nothing.
Nothing. So I just added an x, but then I took it away again.
Right.
See it?
Huh. Yeah.
Now do I have a rectangle?
Yeah.
And you gotta use your imagination that this whole part right there is gone, right? It's cut off. That's a 0.
Right.
So you're using your imagination. It's only a
Yeah,
multiple.
but then you have the rectangle.
So what can you read the factors to me?
Yeah, okay. So with imagining that the top is gone,
Oh,
you
shoot.
have x plus 0 and then times x plus 1.
X plus 1 this way.
Right.
Did I go all the way up x, or did I cut some off?
Oh no, you cut it off.
So how would I note that?
So x minus 1.
There you go. X plus 1, x minus 1. Forevermore, these will be easy. My son is just like, he's known these forever, right? This is simple. This is called difference of 2 squares. Hey! That'll teach you to eat sugar. Actually, no, it won't, because you just keep doing it. Did you get yourself some magnesium citrate?
Yep.
Alright. Chocolate chip cookies and such. Sugar, it is the surest of the poisons, but it is the slowest of the poisons. But we have been taught, because it tastes good, because our taste buds have been trained that if it's a sweet berry, it's probably not poisonous, right? If it's a sweet fruit, it's probably not poisonous. So the demons have figured out that, if we just give them pure, unadulterated sugar, they'll eat that happily. You take white sugar and put it on a baby's lips, and they'll smile at you. Right? It's a drug, make no mistake. Instant smile. But if you now you got diabetes, now you got allergies, now you got skin issues, now you got all kind of issues with too much sugar. Right? Because the companies that make sugar paid our whore doctors and other universities to write studies that say it's not this sugar's fine, it was the fat. Fat's bad for you. No, fat's essential for you. Good fats, not bad fats, but fats are absolutely essential. And if you get too much sugar, your body will produce fat, will make fat. And then that will be problematic, because then your kidneys are stressed and, there's all kind of, anyway. But the idea is, the little boy hasn't figured out quite yet the sugar thing, because it tastes good. And then they put all kind of fun food coloring in there, and a lot of the sugary snacks. And those food colors are not harmless. They are generally recognized as safe, but if you spend a little time, really, they're not that, right? Like the green food dye that most of them use, that actually has effect on your sexual organs. Lower sperm count, all kind of stuff. Yeah, like, ooh, right?
I didn't know that.
Yeah, I can give you a list of all the different commonly. Anyway, keep the food color out of your face as much as possible, and you will find that you have less problems with your health. All right, can you see that there's two answers for this again? -1 and +1 both work.
Yeah.
Right? Because -1 squared is just +1, and +1 squared obviously is just +1.
Yes.
All right.
And then it's just 0.
We're rolling now. All right. So the very basic concept is if I'm fooling around with this model, what I literally did is I cut this part off and I put it over here. See it? That's my model of it. I cut that part off and put it over here. And that whole part up here, this whole part's missing when you get right down to it. Like I said, you got to use your imagination. That part's gone. All right.
Okay.
Yep, see, there you go. That's what I mean. Just wait for you. Like, when I see the light bulb go on, or when I see you go, oh, okay, I get it. Right? Okay. Let's get bigger. What if I have a difference of 2 squares, and the square this time is 4? Which is basically just a... Because here's the thing. Isn't a 1 square just a 1? So I'm not going to write it. Now, I could write it like this, and that's true, but more commonly you're going to see that.
Well, you can make like a little...
Yep, there you go. It's going to be a little square in the corner. You're correct.
It's just a bigger version of what we just did.
Yes, correct. There's my 2.
Right, because that's what it's getting rid of, and then you're slicing off the top.
And just for fun, I'm going to use these, because you're from Brooklyn, in commemoration of the... Said my favorite story in the history of all favorite stories from the Mortensen Company. That's my favorite story. There are other ones, but that's my favorite. He was ornery just like me.
Okay, so we got XX, and then slicing it off at the top.
Yes.
Keeping the bottom.
Yes.
Right.
So see what I just did? I added 2x and then I subtracted 2x. And look, my nice flesh-colored ones are the negative ones.
Right.
Because you wouldn't want to use black ones, because that would be, you know, racist and stuff. So we're gonna use, right, as if math could be racist. Anyway.
There's the flash.
Did you hear? I actually saw this someplace that some bonehead was trying to say that math was racist. No, the application of math can definitely be racist if you have these people that are so ignorant that you can fool them using numbers, which you can, constantly. But the mathematics itself doesn't care, one way or the other.
Right.
You got it?
So,
see, I'm hampered by this thing called gravity.
So you're basically making parallels.
Yeah, there you go.
When you're using the negative.
Okay,
So
I'll take it.
It's x plus 4.
Wait a second. Where do you see x plus 4? That would be a much bigger problem.
I meant to.
Yeah, okay, x plus 2.
Plus 2.
And x minus 2. And that 4, the i's, yeah, okay, I know what you meant. We're on the same page, right? But you got to say what you mean.
Yeah, I was.
Because if you did x plus 4 and x minus 4,
yeah,
then this would be a 4 square, and that would actually be 16. And we could still use the same model. We're just saying that each one of these is 2 instead of 1.
right.
But I can do that because you're 16. What you really want... Oh, shoot, I don't have any of them over here because they're in the car and I'm not running down to the car. Oh, yes, I do. I got 2 of them here. Beautiful. Beautiful. Boop. And I would take and put... Oops. But see, like I said, these blocks can be anything we say they want to be, right? Our imagination is what hampers this, nothing else. So there is my plus 4. Then I take away 4, and then I put a 16 there, and bam, there's that model right there. But like I said, once you can do one of them, you can do any of them, right?
Yeah.
All right, now we're gonna get crazy. Let's just do a couple more just to practice, just to make sure. What if I had x squared minus 81? Now what?
Whoa. Okay. So then you're getting rid of everything but...
Yeah. What are the factors for 81? Mister, I like to make math complicated when it's super easy.
1 and 81.
Oh, sure. Cheater. What else? What times what is 81? See? Gotta recognize your square numbers. That's definitely a square number. What times what is 81?
Oh. No.
Yes.
Yeah,
You,
9.
yeah, 9. There you go. So, plus 9 minus 9. But see, that's a bit of a problem if you don't recognize a square number.
Right.
Well, let's put another one in there. I'm going to get nuts. How about 49? Now what?
39.7.
You know that one. All right. Well, okay then. All right then. All right. How about this? The expression on your
I'm
face
just
is
gonna say
awesome.
25. I'm just gonna say, I'll guess 25.
25 would be 625. You missed it.
And it's not 5.
It's not 5. 5 times 5 is 25. So what's ends in 5 and is between 5 and 25?
15.
There you go. Because 15 squared is 225.
225 is always my favorite square number.
Yeah, there you go. And that's the thing. I could go right now, and for those of you watching at home, you could go off on a lesson on square numbers right now. Bam. Right? I'm not going to. You're going to do this on your own. But what I want you to do is do 1 to 20 and just square the numbers. And I want you to build them. Okay, so promise me you won't just write and well, okay, you could draw them, but mostly I want you to get your hands on the blocks in your spare time. So here, I'm going to do a fast lesson. I mean, like super fast, just, right? So that you recognize square numbers. Gotta recognize square numbers. And I'm just going to build this 1, and you go all the way to 400 with your square numbers. But here's this one. Bam, bam, is 25, right? There's 50, see, I just changed my, all right? Okay, look, a second ago, bam, that's not this problem, that's x squared minus 25, which is right.
Right.
But now let's just do a square number where I have, let's flip the blocks over. Do I have 100? Yes, I do. Book. See, we'll do another lesson another day on squaring numbers that end in 5, but not everything all at once. Too much chocolate cake and they get sick. See it?
Yeah.
15 that way, 15 that way. Ooh. 225.
125.
Right?
Okay. Right.
So then this model, if each one of these was 3, right?
Each one of those was 3. Okay.
I suppose, right? Because that would be 15 and 15.
Right.
So I'm saying that this is 3 of them, 3 of them, 3 of them. Just using my imagination. Instead of that being 1x, that's 3 x's.
Okay.
Right?
Right.
And then this would be 15x that I'm holding here, but I'm not. I'm only holding 5x. But my imagination is 3. It's 15.
Oh,
so
right.
then I could model this, and this would be 225 right there. Right? Ooh, there's a good one. If that's 225, what's one of these?
Uh, 25.
That'd be 625. There'd be 25 25s there, and that'd be 625. I'm saying that this whole square right here is 225?
5. Which square is 5?
Is 5 times 25 225?
It's 125.
Yeah.
Are you saying the tiny square is the?
Yes, I want to know how much. If this is, I'm just doing a math problem just for fun, side problem to have, because this is what we do, is we have fun when we do math. Is I'm saying that this whole thing is no longer 25.
It's 200.
It's 225.
Then each corner would have to be 15, wouldn't it?
Well, yes, this would be 15 by 15, but what's that one square?
That one square would be.
And I just told you. Oh, you guys are starting to hurt my feelings. Each one of these is a 3. What's a 3?
3. Okay.
Well, wait a minute.
It's 3.
No.
It can't.
It can't be 3. This is 3 on this side and it's 3 on that side. What's that square?
9.
Yay! What's 9 times 25?
9 times 25, that's. Well, you do it every 4, so that's. Oh, that's 225. Yeah.
I like it. You have very expressive features when the light bulb comes on. Oh yeah, okay, 225. Because that's, oh, jeez, okay. So all I was doing there, you crazy monkeys, was saying that, oops, not enough. That's only 4 by 4. I need one more, and I need one more. All right, that's supposed to be a square. And all I was saying is that each one of these, just for fun, was 9. Right? Because my model was 3 times. And see, the x squared doesn't matter. So what I had there was I had this, and I told you that each one of these was 3 times as much. So there it is. And each one of these squares then wouldn't be a 1, it'd be 9. The Hermetic principle that we were fooling around with here is mentalism. Principle number 1. The mind is what tells you that. That's a 1. But if I say it's a 9, it's a 9. And it's a square 9, and it's a square 9 that if I blow it up, you can't see it. It looks like that. Right?
Yeah.
And I'm modeling that with this. It's only a model. Don't get caught up in the model. Too many parents get way too caught up in the model. Alright. So anyway, like I said, do your square numbers out to 20. So that's another piece of homework. Your other piece of homework was to evaluate that other equation that we did for the fraction. Right? Alright.
Right.
Like I said, class doesn't end.
You mean the cipher, right?
No. The ones that we were doing where we didn't evaluate for the other fraction. So you're going to do the fraction.
Okay.
The first ones, remember?
Yeah.
Yeah, it was a long time ago. It was almost 20 minutes ago. Anyway, so all right. So now we're gonna get totally crazy. What if I had 9x squared minus, is that square?
That's a square.
Yes, that's definitely square. Minus, I don't know, let's 36, just to make it look scary. Ooh, isn't that scary? What am I gonna have?
So you have, wow, okay, so you have 9 of these. Well, I mean.
No, don't even, that's what I mean. We don't want to build all of them. We don't even want to draw all of them. I can draw this one, but I mean.
We just imagine.
You want to start, yeah, we can use our imagination and start figuring out. What's it going to be, though? What are my factors going to be?
Okay.
You want to answer? Here, wait. He'll answer, I hope, and give you that. What's it going to be? What times what equals 9?
3.
It's 3.
No, I know that part.
Oh, okay, so it's 3x.
You know that part. You should be, just tell me the answer then. And then how do I get 36?
12.
Okay. 3x plus 6, 3x plus 6. 3x plus
Failed.
6, 3x minus 6.
There you go. Fumble on one and on. There it is. Boom, done. Do I care what the middle terms are when you get right down to it? Well, no, but yes, because look, I'm going to have positive 18 and negative 18, x.
Right.
So if I know my square numbers, there's no issue. Well, let's get totally nuts. If you really don't want, I mean, could I draw that one? Yes, if you want to, you can. I'm not gonna. Let's do 121. Ugh. And then over here, we'll make this like, looks like, I don't know, what's a scary looking square? Oh, we'll just do 25. Oh, yeah, well, now what?
Oh, 11.
There you have it.
11x. Yeah, 11x, and I'm both typing in
11x, just say it. 11x plus how many?
11x plus 25? No.
Yeah. Plus what? Really, suddenly? What's the square root of 25? What else could it be?
Oh, okay. Okay, no, it's that I didn't get it yet. Okay.
But now all of a sudden it clicked.
Okay. No, now I get it.
Right. There you go. See, and that's why you got to do a few of them, right? Okay, let's get nuts. Let's get nuts. We're not done yet. Now let's prove it. Prove it, Maynard. I don't know. What am I gonna pick? Oh, let's do 36, and I don't know, 49.
Okay, so that's 6x plus 7 and 6x minus 7.
Done.
Now I get it.
Right?
Okay. Yeah.
Any issue?
No.
I was at a private school, a very expensive private school, and they had no issue with these. All right, as long as, right? But as soon as you put one over here, oh man, the girls were crying. They didn't know what to do, right? Because the teacher thought that, well, if they can do that, they could extrapolate. No, you got to teach them, right? So if all they ever saw, like they saw a 1, they saw a 4, they saw 25, I skipped 16, they saw 49, but they never saw anything over here, and no, they couldn't, they could not, right? It takes a minute for you to figure it out. Right? Because, and it was, it was the homework, and they'd never seen this part before, so they'd only seen up to here to, like, I think they did, x, oops, and this is supposed to be squared, minus the 144, so they went up to 12, but they'd never seen it over here, and they didn't know what to do, because they'd never seen any blocks, and they were just following rules, and they didn't know what the rule was. Well, obviously, what's the rule? Because isn't this just, if I get crazy, but explain to me how that helps the kids, because it doesn't. Children. Doesn't help the children. It doesn't. That's what you're doing, but it doesn't.
Right.
Like I said, if this is all you ever see, you're going to have a bad time. But as soon as you see the blocks and you see this cute little thing, boom, cut the corner out, and put it over there, done. Right? So I have x plus sum, and I have x minus sum.
Right.
And the sum tells you.
And that's how you get the squares. Right.
Make sense?
Yeah.
Alright, I'd say we quit.
Okay.
I mean, we can go, if you want to go longer, we can, no charge. Because I don't have, my next student, like I said, she's not going to be here.
Yeah, I do think I have to go right about now, though.
Okay, alright, no problem. Yeah, like I said, made the offer. And you were not obligated to accept the offer. But we've gone a little more than an hour now, so yeah, good. Alright, so, and then after this, we have to do more. Like, we have to do, there's more. But anyway, so far, we have covered 2 forms. We've covered some ax squared plus bx plus c factor in. And we've covered some ax squared minus b squared.
Right.
Right? Those are the, okay, so there are many more forms, because there's like, what if I have something like x squared minus 3x plus 2? Well, there's that. And then what if I have like, I don't know, x squared plus 2x minus 35, right? We'll get there, don't worry, it's coming. Right? I can see these in my mind though, easily, 0. And if I look at that, I'll just give you the answer just for fun because I know you want it. It's going to be x plus 7, x minus 5. And we'll do that,
Okay, so
like I said, next lesson.
Right. Those are the
Factors.
the multiplicants, right? The factors.
Yes. And again, there's the answer.
Right.
7x, 5. Anyway, we'll get to it. All right. See, and this is the problem. I've seen with my own eyes algebra teachers. There's your whole lesson. Nuts. And then why are the kids confused, or why are the children confused? Because that was the whole lesson, and that wasn't enough. See, because the teacher understands it, and they think, well, if I understand it, and I just show them that, and we're done. No, we got to do a whole bunch of factoring. We got to do a whole bunch of building. We got to get our hands on the blocks, and then those will be easy also. See, and the whole reason why I'm going to spend so much time on factoring is, one, because you can see it teaches other stuff, but two, when we get to other problems, being able to factor a polynomial should be instant. That shouldn't be the problem, right? That way you don't. That's called we're lowering your stress load or your mental load, right?
Right.
That's what it's called, cognitive load, and we're making it so that part doesn't increase your cognitive load at all, because if you see x squared plus 3x plus 2, you just know it's x plus 1 and x plus 2. That's it. You know the factors, right? So same thing. When you see the ones that are easily factorable, you'll just see them, and it's not an issue. And then you can focus on vertex form, and then you can focus on, like, say, if you're dyslexic, writing your numbers the right way, and so on. Right. But you don't have to focus on the algebra, because you know the algebra, because you've been doing it so much, and it's easy. Right. So if you see difference of 2 squares, gimme, I know that. Oh, last thing before we quit. I've seen, this is true, an entrance exam for college where there was only 3 math questions on it. They placed the students with 3 questions. This was one of the questions. Can you factor it?
No.
You either can or you can't.
You can.
Well, what is it? It's the difference of 2 squares, so what are you going to do?
Right. So you subtract this one.
Don't get crazy with your rules and all this other stuff. What do you do?
Okay.
It's the same thing we just got done doing for half an hour. What's it going to be?
Oh, so it would be x plus y.
There you have it.
X minus y.
Done. Why were you trying to make that hard? Look, him too. He was also trying to make it hard.
No, I had to erase it because I didn't make it hard
Sure.
enough.
Yeah, I don't believe you. Right? That's it. You either understand the concept or you don't.
Right.
And you had 5 different questions, and of course that was one of the answers, right? There were 3 other ones that were crazy, and I mean, 4 other ones that were crazy, but I mean, that's it. That's all it is. There's the generic form, and what if I did this? What if I get crazy? Now I can't, now.
A plus y.
Mm-hmm.
So A plus B.
Mm-hmm.
A minus B.
Done.
That's it.
That's it. That's all it is.
It was on a
See, once you understand the concept, now I can change the letters and it still doesn't matter. Same concept. Now, for the coup de grace.
It's the same thing.
Yeah, well, I'll say it.
Right.
Sine theta plus cosine theta times sine theta minus cosine theta.
You could mess with all kinds of people with that.
Right? It's just the same thing every single time. Difference of 2 squares.
I got it.
Alright? I'd say we call it a day. Crewton Ramone's House of Math.com for more.
Watch it, Tom.